Hello and welcome. Today we're doing delete the middle node of a linked list from LeetCode. This is part of the LeetCode 75 playlist if you are following along. So what is this question? You're given the head of a linked list, delete the middle node, and return the head of the modified linked list. Simple enough, and the middle node of a linked list of size n is the n by 2 node from the start using zero-based indexing. So for n equaling 1, 2, 3, 4, or 5, so say this is my linked list over here, we're using zero-based indexing, we're going to be deleting nodes 0, 1, 1, 2, and 2. So if we have just one node at index 0, if our length is 1, we're going to be deleting this node, returning none. If we have a size of 2, we're going to delete this one at index 1. Size is 3, we also delete what's at index 1. If it's 4, we delete this one right here, index 2. And same with 5, if we have a length of 5, we're also going to delete the node at index 2. And over here, we just have examples showcasing that. So if I have the following linked list, I'm going to delete node 7 and return that same linked list without that node. And example 2, 1, 2, 3, 4, I return 1, 2, 4. And example 3, I have 2, 1, I delete this very last node. Because remember, if we have size being 2, we're going to delete whatever is at index 1. So we return just 2 by itself. So we want to delete the middle node of a linked list. Now, how do we find the middle node of a linked list? Remember, this is a singly linked list, which means we only move in one direction. We don't have arrows going back, just going forward. So a quick tip, whenever we want to find a specific node in any singly linked list, we always want to use more than one pointer. So what I'm going to do is initialize my slow and fast pointers to both start at head. So slow is going to equal fast, which equals head. So right now they both start over here. And if I want to find the middle of a list, I want to find that halfway point, I'm going to move one pointer at half the speed as the other. So what I'm going to do, while fast and fast.next, I'm going to move my fast down 2. So fast is going to equal fast.next, and slow is going to equal slow.next. How will this look with this example over here? And I'm also going to do an example with 4 nodes. That way we cover both the even and odd cases because they are a little bit different. So I have my linked list over here as well. Now, slow and fast both start at head, while fast and fast.next exist. So this is not none, this is true. We can go in this while loop and move fast down by 2. So right now we just moved our fast to its next node for both of them, right here. And slow is going to go to its next. So slow is going to go to slow.next. We go back in this while loop. Fast is not none and fast next is also not none. So again, we're in this while loop. We move fast down to its next node. So the next node would be over here. And that node's next node would be where we end up. And so we just go to its next. So once we're out of this while loop, we have, for this example, fast on this last node over here. And for this example, it's on none. And for both of them, slow points at the middle node. Because size 5, we want to remove index 2. And size 4, we also want to remove index 2. And we're already at the node we want to delete. So we can go about this 2 different ways. One thing we could do is just take the value of our next node. So over here, if I want to delete this node, what I can do is take the value of that next node over here. So this becomes 4 and change my pointer to point to my next node pointer. So essentially what we did is have 1 pointing to 2, pointing to 4, pointing to none. We got rid of node 3, which we wanted to delete. And we could do the same thing for this one. Just take the value of the node ahead of us and change the pointer to point to its next node. So it's going to go directly from 1, 2, 4 to 5. We got rid of that middle 3. So that's one way to do this. And another way to do this is have another pointer. This one is going to lag behind our slow pointer. So it ends right before the node we want to delete. So say we call that P, then all we have to do is change P's next pointer to point to its next node. So we entirely skip over that node we want to delete. Now I've submitted both of them, both ways work. I'm just going to be using this latter approach just because it's a little bit cleaner. So in order to implement this, I'm just going to initialize another pointer at none. So this is going to be previous, starting at none. And it's going to take whatever value slow had before it makes its update. So before I update slow, I'm going to update previous to equal slow. Now to do a quick walkthrough of what that would look like, basically slow and fast again are at head and previous is none. Now while fast and fast.next, all I'm doing is assigning that previous pointer's value to what slow has right now. So previous equals what slow is right now, then fast is moved down, and then slow is moved down. Then we go back in that while loop and again previous equals slow, and we move down fast and slow. So now once we break out of this while loop, because fast exists over here, but fast.next does not, that's going to be none. And over here, fast is already none. We don't go in this while loop, and previous correctly points to the node before the one we want to delete. So all we have to do now is set previous is next equal to its next. So we're just doing some pointer manipulation in order to delete that node. And in the end, all we have to do is return head, since we already went ahead and modified our linked list. Now, one last thing we want to do is keep track of our edge cases. What if the linked list only has one node? If that's the case, we want to return none, right? If we have just one node, we want to get rid of that node itself. So if head.next is none, we just return none. Let me fix this indentation over here. Get rid of this, and we can go ahead and submit this. And it is accepted. Now we just did a complete walkthrough with two different size lists. So talking about time and space complexity. For time, since we are iterating through the entire length of our linked list, this is going to be O of n if there are n nodes in our linked list. And for space, we're only keeping track of 3 pointers, so this is going to be constant O of 1. And we just went ahead and solved delete the middle node of a linked list. If you have any questions whatsoever, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.